Hi, hello everybody. I'm Mauro Tortonesi from the University of Ferrara. I am assistant professor of the Department of Engineering, and today I'm going to talk about something from a different perspective than the one that you've listened so far, because I'm a doctor, I'm a PhD. Not a reliability engineer, so I'm not. This speech is not going to be just from a technical perspective, but from an academic one. So I ask you to be a little bit open-minded and to bear with me for a few minutes before going out of the room and going for lunch. Because actually what I'm going to talk about is something which is, even from different perspective, in line with what Chris was talking about in this morning's keynote. I'm going to talk about autoscaling, and I'm not an expert in Kubernetes, and I'm not even an expert in the functions that are provided, autoscaling functions that are provided by AWS, but both of these state-of-the-art solutions are based on what we call IT metrics. We'll introduce the difference between IT metrics and business metrics in a couple of slides. So here is a picture straight out of the documentation from Kubernetes, and it's the documentation for the horizontal pod autoscaler. You have a resource controller, and you can autoscale Kubernetes. You can instruct Kubernetes to autoscale the resource controller from 2 to 5 instances of a given pod. And you basically set what kind of metric is used for the autoscaling. In this case, the metric is the CPU usage. When Kubernetes keeps monitoring the CPU usage of the pods, when the CPU usage goes above 80%, it automatically creates a new instance and of the pod, and of course there must be load balancer in front of it. AWS is an even more sophisticated solution. It was recently introduced in January, I think, but you can ask Massimo for more details. And this solution works at not just at the pod level, but at the entire application level. And you can decide what to optimize for. So you have different strategies: optimize for availability, optimize different parts of the applications using different strategies. And but what you're basically saying is the same thing: automatically scale, create new instances, new replicas of components for my application when the CPU usage, for instance, goes above 40% in this example. So it's much more sophisticated, but based on the same concepts. And as I was saying, both solutions are based on IT level metrics, and on constant monitoring of pods or VMs or containers. And when the reference metrics, which can be CPU usage, can be request times, or even custom metrics, you can define your own metrics. But when the observed metrics exceed the given threshold, then it's when the autoscaling is triggered. But are we sure that this CPU usage, these request time metrics are the best tool for the job? There is a discipline called business-driven IT management. I was one of the organizers of the business-driven IT management workshop for many years. And this discipline emerged roughly 10 years ago, probably a little more, out of HP Research Palo Alto. The main researcher that came up with the idea is Claudio Bartolini, my former mentor, a great guy, all-around guy. And basically this BDIM, which business-driven IT management is a discipline that basically states that we need to ensure that the management strategies and objectives are not aligned just with the IT requirements, the IT needs, but also with the business needs. Business and IT need to be aligned. It's basically the message that Chris was given this morning. We engineers tend to optimize, tend to fall in love with the tools, and there is a gap between the engineers and management, and we need to fill that gap because what we are doing as a business objective, we need to understand what we're doing and deliver the delivered value, business value. So we need to measure our application not for the optimization of CPU usage. Okay, but when you say we autoscale so that that our instances are always at the CPU usage 80%, you are implicitly saying that you want to be able to sustain requests from the customer. So you're making a business consideration. You want to be available for the customer. So our idea, the idea of BDAM, is to go further and to measure, actually to introduce a new set of measures and to autoscale to build a smarter autoscaling solution on top of. Can we use business-driven IT management in autoscaling? Yes, why not? We can express the problem by considering that our service has a given configuration. Bear with me with mathematical formulation for a couple of slides. Our system is a set of components, and each component has a number of instances, and we have a current configuration and a set of possible configuration. I mean, you can run 5 web servers, or you can run 7. And basically, what you want to do is to choose the configuration for your system that minimizes the business impact and optimizes the business result. So it becomes a mathematical minimization, mathematical optimization problem. And what is this business impact or business result what is the business impact analysis of our system? Well, you definitely have the IT cost component, which is how much you're spending for VMs. But you also have a contracting cost component, which means that, for instance, if you have a service level violation and you don't meet the objectives, then you're going to have to pay for penalties. So if your system is underperforming and your customer is going to notify you of service fee violation, you're going to have to pay penalties. So if you have IT costs, contracting costs, and you also have a drift. If you don't have enough instances to support the customer needs, if you are if your system is not performance enough, you also you can monetize the performance drift and express, measure, evaluate your system in in a monitoring perspective, because here you can see here the IT metrics that you're considering is CPU usage. Here you measure the system by how much value it brings in dollars per hour, euro per hour. So are you sure that CPU usage is the best metric to use for auto-scaling? What if you are scaling too much? What if you have a peak of requests and you this auto-scaling solution scale too much, automatically instantiates too many VMs or too many containers, and you have an exploding cost for VMs and containers? Is that a desirable achievement? Is a desirable objective? Perhaps not. Perhaps the increasing number of replicas, you have low contracting costs because you're sure that you're never going to have SLO violations. And basically what you want to do, sorry, I forgot my pointer. What you want to do is, if you are in this solution and you go, you create too many replicas of your application, you're spending your costs. Your cost might be exceeding, your IT cost might be exceeding the increase in costs might be exceeding the decrease in contracting costs. So maybe if you do auto-scaling is not the best solution. Automatically auto-scaling on CPU usage is not the best solution for you. So what can you do? BDM-oriented auto-scaling is essentially a different perspective. The idea is to proactively evaluate all the possible configuration that you can have, doing what-if scenario analysis, so you don't have a reactive approach. I mean, my workload exceeded the current possibility of the system, of my system to support it by keeping the CPU under 40%. So I have to instantiate new components, new VM, new containers. Instead, you have a proactive approach. You evaluate all alternative solutions through what-if scenario analysis, simulation, and you accurately simulate how your system would perform if you instantiated 10 more VMs or 9 more containers of given system components, and then you evaluate the business result of the system under a different condition of your IT service under a different configuration. You switch to the best configuration. So you probably, I probably have lost you because it's might look like BS for you, but we actually have a working implementation which is called BDMaaS, Business-Driven Management as a Service. Yeah, I know it's a lame name, but we couldn't come up with a better one. It's written in Ruby, and not many of you have a great opinion of Ruby, at least talking outside of the room, but JRuby in particular is the go-to tool for the job in my line of research, at least from my perspective. So, just to give you an example, the reference scenario is basically AWS, a distributed application in which you have several components deployed in different AWS clouds, cloud data centers, and basically you have several customers all across the planet. You have several users and several service providers. So a service provider could use BDMaaS to identify, to analyze the service situation, the service configuration, come up with the best service configuration, and perform a deployment of VMs, so the number of VMs required, through an agent, a BDMaaS agent running in each cloud data centers. This is a very simple scenario in which you have a two-tier application example. Why two-tier? Because we assumed in this scenario that you can use geo-replicated storage. So the storage is, you can assume it's going to be already replicated by, for instance, Amazon. And just to keep the scenario simple, let's think about the two-tier architecture in which you have web service and application server. And you want to find out the best number of VMs of a given component type that bring you the lowest cost, not just from the operational perspective, but all around. As I said, sometimes you might have some different levels of SLAs, and sometimes matching an SLA is matching an SLA from the operational cost perspective is less convenient than just failing, than just taking an SLO violation and pay the penalties. So here is a simulation using real costs, from Amazon costs, Amazon AC2 cost for running VM per hours. We have a simulation that you have a reference system running at the purple line is a system, and you have, as you can see, an optimization component in BDMaaS that takes a while to find out, using a genetic algorithm, takes a while to find out what's the most convenient number of VMs to run. Then you can run a system with a 5% more, you can run motif scenario analysis, you can you can simulate what's going to happen if you have 5% increase in workloads, 12% in workloads, 14% in workloads, and you come up with, we come up in advance with the number of VMs that represent the sweet spot configuration for your service. You can also think about having a multi-tenant solution in which you have different customers at different levels of different service classes, gold class, silver class, bronze class with different SLAs. And so you factor in the SLA in the evaluation of your system, and you come up with the number of VMs that represent, once again, the sweet spot from the business perspective in this system. We also did some evaluations from the optimization perspective, which kind of optimization algorithm to represent the best choice for the optimization of this, to find out what's the best configuration for your system. I'm not going too much into details here, but there are different configuration of parameters for genetic algorithms that show that you can have better speed in finding out better convergence speed in the optimization algorithm. Here is, anyway, another example of what happens when you have different conditions. You can see that if you switch to a changing context here, basically we simulated waking up in Japan, what the amount, the increase in request load, that the request hours, that the office hour in, for instance, Japan, increase in the whole system, and see that how can the optimization solution respond in a very efficient way to changes in the context of the user. Here is the general architecture of the solution. You have basically the engine, the engine of the tool as knowledge of the working, the inner workings of the service, as a knowledge of the usage, how the users typically access the system, what's the typical request load that we expect. We using the knowledge about the system usage and the knowledge about the service models and the workflows they implement. You can simulate, you can run several simulations using different placements for the components of the service, evaluate how much money each configuration is going to take to run, and then find the best one, and you have and enforce it. When you find the best one, basically you actuate it. You switch to the given to the new configuration and update the service model, because your service is in a different configuration now. This is in order to work, this conceptual BDMaaS engine, of course, needs to have an actuator that actually instantiates the VMs, has to have monitoring of the level of workload requested by customer, and have to also to monitor how the services are working. And all of this solution is governed by configuration and policy management by service providers. I know it's kind of a different paradigm from the current state of the art, and you might find that it is based on a lot of working assumptions, but basically the assumptions that such a solution has is that IT service has a generally predictable workload, at least in the short time. Also, the system, the simulation system, ignores communication latencies between components within a single cloud, but performs a very accurate measure, reenactment of communication latencies between different clouds, cloud data centers. We also have breakthrough research in the modeling of latencies between AWS data center. It was recently published in IEEE Communication Letters, which is a very prestigious journal. Another assumption that we have is that system behavior can be actually simulated using an open queuing network, which means that basically you have a Markov approach, memoryless approach. This, as I'm going to show you, is basically means that a request flows through system, flows through component of the system with different tiers. So, for instance, for web application, only in a memoryless way. Also, there is another working assumption that steep changes in workload can be detected and notified to the optimizer module in an efficient way. This is not required, but it significantly improves the quality of the optimization. This working assumption is not really that unreasonable, I think. The tool, how would a system administrator use a tool, a service provider use this tool? Well, you would we have configuration DSL. Of course, that's why we use Ruby, because it's very easy with Ruby to define DSLs and integrate them in tools. So here is an example of a definition of a service component. For instance, we have a web server A and web server B, which might be Nginx and Apache. And for instance, we say which kind of Amazon VMs they are allowed to work on, and we give an estimation of how they perform, how much time they would take to process a request. So you can see that you have basically you're doing a modeling of each component. Here you say that you have each component as a service processing distribution, which service process times that is an exponential distribution, and you use different means. Exponential distribution is one well-known tool, but there are several other, of course, distribution available in the tool. We also have a knowledge of a workflow. You define what kind of work, you can define the different workflows. So you basically reason at the application level and define how the requests go through the system by defining workflows. The knowledge of workflows and the sequence of components that the request flows through is into the simulator, so you're not considering instance types, for instance, web server A or web server B alone, but you are evaluating how they perform within a system, within a given workflow. For the nerdest of you, here is a couple of information about the optimization solution that we use. We use a sophisticated genetic algorithm variant. It was a lot of fun to find out the best genetic algorithm solution to use in this context. We had a lot of fun. We played with a lot of variants, bit string type. We find out that especially it was fun to play with hypermutation, which is a concept that is used by a very low number of optimization solutions, and we found out that it's very, very effective in this area. Preliminary results. With preliminary results, we also found out that other solutions, such as particle swarm optimization, seems to significantly outperform genetic algorithms, and we're going to use adaptive variants of a very advanced optimization solution called quantum particle swarm optimization pretty soon. The optimization solution is open source. The optimization library is open source. We haven't open sourced the entirety of BDMaaS yet. We're going to do very soon. Why haven't we? Because of course some components are not, the code of some components is not very clean enough to be put on GitHub. So but we have the main components. The optimizer library is already on GitHub. It's definitely one of the most advanced optimization solutions I've seen, at least on GitHub. It's designed to be run in a multi-process way, multi-process or multi-thread way, so it's also a nice tool on its own to play with if you want to play with the optimization solution. We also have the simulator, the core simulator of BDMaaS already on GitHub. So there we have already released a lot of components of BDMaaS. I know you might be like this. This is I'm a big fan of the Big Lebowski movie. This is the point after the famous scene in which John Turturro, dressed as Purple, makes his dance because he just bowled. He gave a fantastic bowling game. You might be skeptic and incredulous about this perspective. Yes, it's just my opinion. I'm not saying that I'm not trying to sell you a set of pots and pans. Actually, I hate salespeople as much as the next guy, which means that I don't hate salespeople as much as you, but I hate the next guy as much as I hate the salespeople and anyone. And I'm a misandropist, so if there are any salespeople in the room, don't take it personally. I hate everybody. So anyway, this being a conceptual presentation, I still think that BDM autoscaling is a very interesting concept. Why? Because right now, speaking to several friends of mine, that run services in production, told me, well, Mauro, this is a very interesting concept, but the thing is, we have so strict SLAs that failing an SLA is going to be immensely more costly than reducing IT costs. For instance, what you want to do with the BDM autoscaling is reducing IT costs if IT costs would outbalance SLA violation costs. Right now, SLA violations are incredibly costly because it might be because it's a broken model. It's a broken model because it's a digital model. Basically, or you provide services or you pay a lot of money because you failed. Shouldn't be this way. You could have a less digital model. You can, if you add this kind of autoscaling solution that evaluates your service from the business perspective, then you could play with different SLAs. You can offer different SLAs, not based on the digital. I'm going to provide you 10 nines, or I'm going to pay 100,000 euros for every time I fail these SLAs, but you can play with different SLAs. I'm going to give you 90%, 95%, but if I go below that, I'm going to pay you not 100,000 euros, but 5,000 euros, 2,000 euros. So you can, and of course the customer pays less for the system. So which means that you can really think about bronze, silver, gold SLA models and give your sales representative, your business management, some middle ground to play with customers, to contract customers with different SLAs. Also, with the BDMaaS, we're still at the proof of concept stage, of course, not talking about a solution which is in production. Nevertheless, I still think it's an interesting concept. The code works. It was published in the graphs and the picture that I showed you were published, were taken from an article published in a prestigious IEEE Transactional Cloud Computing. So it was the entire solution went through peer review from very strict reviewers, and they appreciated the concept behind this solution. So The reason why I'm here is because I would appreciate any constructive feedback you have on this approach. If you have interesting use cases for BDIM autoscaling, if you would like to try BDMaaS,